Yesterday you worked on this with a partner. You should have all of these filled in, and you will staple it to this and turn this in. It should have, if you had one solution, you needed to make sure you told that solution, and that is due at the beginning of the hour. If you turn it in later after working on your homework, it is considered late, and I'll have just have that so noted as you're doing your homework. This does count as kind of a bigger grade, like a project grade, so since you are working with a partner, it is probably towards a quiz grade, so make sure you've checked everything over. As you are looking today, we are going to start solving systems algebraically. So up to this time, we've always used graphing. This is called the substitution method. And so far in this unit, we've learned that what is a system of equation? It's always two equations. The solution of a system of equation, that is our x comma y point, or how many solutions a possible linear system may have, and how to find that solution by graphing. So looking for that point of intersection. Today we're going to look at another way to solve systems, but not by graphing. We're going to look at what's called an algebraic method, which is what you have to learn how to do. And the key thing I want you to think about is, what does substitution mean? We have been substituting when I gave you a solution, and we had a solution like if we were looking at your homework last week and you did a graph, and as you looked at your graph, we had the solution being something like 3, 2. 3, 2 was a solution for x plus y equaled 5 and x minus y equaled 1. Now, if we are substituting, this is our x and this is our y, and this is how you did the check. So the check was really substituting the x in for the x point. So if we were looking at that, we had 3 plus my y. Instead of writing y, we're going to put what y was equal to, which is 2, and that equaled 5. So anytime you are doing your checks, you are really using that substitution. So here is kind of a situation that I want you to understand. And if on your own time later you want to try and solve and figure out the solution to this. So we got this tug of war. Round 1. On one side there's 4 acrobats, each with equal strength, and on the other side there are 5 grandmas, each with equal strength, and it's a tie, so it's equal. So if we're thinking about this, we have 4A, 4 acrobats, is equal to the strength of 5 grandmas. Next situation, tug of war round 2. On this side you have Ivan the dog, and on the other side there are 2 grandmas and 1 acrobat. Again, it's a tie. So here we have 1 dog, so if we wanted to put that as Ivan the dog instead of D, because D sometimes looks like a O or a 0, we had 2 grandmas plus an acrobat. And then in the third round, on one side you have Ivan the dog and 3 grandmas, and on the other side there are 4 acrobats. And the question is, who is going to win? And you want to use this previous information. But the key thing here is we have 3 different variables. We have A, G, and I. And when you're solving a system of equations, you really have to get it down to 2 variables. So I kind of want you to think about this last one. We have, if we are looking at our system, this is what it looks like. We have Ivan plus 3 grandmas, and we're trying to figure out who's going to win if we have 4 acrobats. So sometimes you might solve in terms of A or in terms of G, and they're each going to be fractional. Here you could solve in terms of A. So I want you to just think about that problem. We're not going to solve it right now, but this is something, we'll talk about it tomorrow in class about what is your solution to that. So as we are taking a look, I'm going to show you this video. This video is on substitution. It's going to take you through this problem, and they're going to talk about exactly how to do. So we are going to watch the video. Kind of keep in mind all of these steps and what they're going to do. This should help you as you are working on your homework also as you do these type of problems. So here is the other video that we're going to watch.
In this lesson, you are going to learn how to solve systems of equations algebraically by substitution when one equation is in slip-intercept form. Let's recall that a system of equations is 2 or more equations with the same variables. A system of linear equations, which we will be studying in this lesson, is when you have 2 or more linear equations with the same variable. There are 3 examples below. A solution to a system are values of x and y written as a coordinate point, xy, that satisfy each equation. You can always solve systems by graphing, but this is a difficult method to find exact solutions. We typically use algebraic methods to find exact solutions. There are two methods for solving systems algebraically: substitution and elimination. I am going to explain the idea of substitution by showing how you substituted in your mathematical past. Here we have two problems where we've used substitutions previously. In the first problem, x squared plus 9, where x equals negative 8, I'm going to substitute negative 8 for x. So I'm just going to plug it in. And typically when we substitute, we put parentheses around what we're substituting. So I get negative 8 squared is positive 64 plus 9 equals 73. And the next problem, y equals 2x minus 4, where x is 3. Again, I know what x is. I'm going to substitute it in for x, 3 in for x. And I get y equals, well, 2x is the same as 2 times x, so 2 times 3 minus 4. Again, using parentheses. So in this case, y is 6 minus 4, or y equals 2. Let's see how this idea works in solving a system. Solve the following system by substitution. Y equals negative 3x plus 5, and 5x minus 4y equals negative 3. When you have an equation in slope-intercept form, y is by itself. Slope-intercept form, if you remember, is y equals mx plus b. So we know that y equals all this. Additionally, a system are two equations that work together, so the x and y values are the same. So if y equals all of this, I can substitute it in for the y below. And I'm going to substitute using parentheses as we did previously. So we have 5x minus 4, and instead of y, I'm going to put in our substitution, equals negative 3. Now, like in the previous examples, I am going to simplify and solve for the variable that I have. I'm going to use the distributive property here, so negative 4 times negative 3 is positive 12x, and negative 4 times 5 is negative 20, equals negative 3. 5x plus 12x is 17x, minus 20 equals negative 3. Well, now I'm just solving an equation. Notice, when I made my substitution step, I went from having two variables, x and y, to having only one variable. This allows us to actually solve the equation as we've done in the past. Now I'm going to use inverse operations, add 20 to both sides, the 20's cancel, I get 17x equals 17, divide by 17, again inverse operations, and x equals 1. But we're not done, because we know that a solution to a system is of the form x, y. We already have x, now we need to find y. To find y, we can plug in x into either of these two equations. But notice, in this first equation, y is already by itself. So let's plug in x in our first equation. Negative 3 times 1 plus 5. So y equals negative 3 plus 5, and y is 2. So it looks like our solution is 1, 2, 1, 2. Now, if you want to, we can actually substitute it for the second equation. Let's just try it, show you that it works, no matter what equation you use. Again, substitute 1 for x over here. 5 minus 4y equals negative 3. Subtract 5. Negative 4y equals negative 8. Divide by negative 4, and y equals 2. So again, it doesn't matter where you plug in, it works for both of them. Finally, as a check step, we could graph both equations, and when you do that, the solution is the point of intersection. In this case, it is 1, 2. So our answer is 1, 2. So now you know how to solve systems of equations algebraically by substitution when one equation is in slope-intercept form.
So this is what the video showed also. A couple of things I want to point out. Anytime you have a minus, my hint would be you might want to change it to plus a negative. Many of you will make less mistakes. Negative times a negative gives us that positive. Other thing, at this point when you have this minus 20, you can add that to both sides. So just watching your integer operations, you checking with your calculator, and then adding your like terms together. Again, once you plug it into one of the equations, you're going to always check it in the second one, and your answer was 1, 2, as they showed. So now this equation, we're going to do the same thing. So first thing we want to do is find our isolated variable. Is it the y or the x? And in this case, it is the y. Y equals 3x. So what we are thinking is in this equation, we're not going to use y, we're going to replace it with what we know. So if we take a look at the equation, we are going to write x plus y equals negative 32. We're going to write that second equation down. Next thing we are going to do is we are going to replace the y with what we know it's equal to, which is 3x. Now, they didn't put it in a parenthesis, and I kind of would recommend a parenthesis because sometimes there's a number in front of that y and you have to use the distributive property. In this case, there wasn't, so we can just add our like terms, and as we add those like terms together, we're going to have 4x equals negative 32. We are going to divide both sides by 4 to solve. Negative 32 divided by 4 gives us negative 8. So if we are looking at that equation, the first thing we've done is we have started our solution. Remember, solutions are still going to be that ordered pair x, y, and we have x equals negative 8. Now, of these two equations, both of them are pretty easy to check, but the first one is already set up with y equals, so that's the one that we are going to use, and we're going to say y equals 3x, but now we're going to replace the x with negative 8, and we get negative 24. And so our solution is negative 8, negative 24. Now, they don't mention too much about doing the check, but every single one of these we can check. So if we were checking this equation, sorry about that, if we are going to check this equation, just deleted that page by accident. As we check it, you are going to replace the negative 8 and negative 24. You're going to replace those in that second equation, which was, if we were looking at that, x plus y equals negative 32. So as you looked at that, if we are looking at that, we are going to replace negative 8 plus it was a negative 24, and negative 8 plus negative 24 does equal negative 32. As you take a look at that next page in your notes, we have two more pages that you're going to be filling in for today's notes. Here we are looking at what x equals, and x equals 5y minus 8. This one is going to be much more important that you replace the, when you replace it, you put an x. So we're going to just have our two problems on our paper, and we're going to go to the second one. Keep in mind, I always suggest putting what your answer looks like first, x, y, and put that as an ordered pair because this is what our solution is. Because sometimes people just forget after they get the first letter. So we have negative 3y is equal to, not equal, is a minus. Again, subtraction, I'm going to change that to plus a negative 2. And now I'm putting what x was equal to. And x in this case was actually equal to 5y minus 7. I'm going to continue with the rest of this problem, which said equal negative 12. Now again, I have this plus negative 7. I might change minus 7. I might change it to plus a negative. So now I'm going to distribute. I have negative 3y plus negative 2 times 5 gives us a negative 10y. Negative 2 times 7 is going to give us a plus 14 equals negative 12. We are going to subtract 14 from both sides of the equal sign. Just like when we solved equations back a few units, we're going to add our like terms. We get negative 13y is equal to negative minus a negative. That's the same as plus a negative. So negative 12 minus 14 is the same as negative 12 minus plus a negative 14, which gives us a negative 26. To solve, we're going to divide both sides by negative 13. Y is now equal to 2. We have our first solution. In this case, since the first equation gave us x, we're going to go back to that first equation, and we're going to write x equals 5y minus 7, but we are now going to replace the y with what we know y is, which is 2. So we have 5 times 2 minus 7, 10 minus 7, x is equal to 3. Not sure if I did it, and especially when some of you get some fractions and decimal answers, you're going to kind of question yourself a little more. You can get fractions and decimals, so we're going to go to the second equation. If we look at that second equation, we put negative 3 in place of y. Y was 2. minus 2, replace the x, substitute in, we get 3. And the question is, does that equal negative 12? Negative 6 minus 6, which is the same as negative 6 plus negative 6, does equal negative 12. And it checks. So if we are looking at our solution, it is 3, 2. This next one always is interesting for students because we know what y equals, 2x plus 7, and we also know y equals x minus 1. So isn't it true that y is always equal to y? And if that is the case, we are now going to put the first y, which is 2x plus 7, equals the second y, which is x minus 1. And now that we have an equation with variables and numbers, not just two y's equaling each other, we're going to subtract our smaller x, get all your x's to one side. Keep in mind our solution is always going to be that xy. We now have 1x plus 7 equals negative 1. We're going to subtract 7 from both sides. And x equals negative 8. First part of our solution. Does it matter which equation we go to? I think the second one is easier because I don't have to do any multiplying. And so if I go into this equation, I'm going to have y equals negative 8 minus 1, which is negative 9. Does that work if I check? Negative 2 times negative 8 is negative 16. Negative 16 plus 7 does equal negative 9. So I might not always write down the check, but I should be able to check that solution. So this last part is talking about our statements of when we have the identity true statement, right? That's when we are going to have infinitely many solutions. So just like graphing when it's the same line, and if you have a false statement like 8 equals 2, then we are going to have a no solution. So you can imagine that we're going to have a couple of those in your homework. So tonight as we are taking a look at this, we are going to start with doing our substitution. And as we do that, we are going to replace, we know x equals, and in this case we know y equals. So in this first one, we're going to replace our x equals. We're going to put 3.5, but instead of x, we put it in a parenthesis. Again, you are going to distribute. And as you do the distributive property here, you're taking 3.5 times negative 2 and then 3.5 times 4. As you do that distributive property, you're going to write down negative 7y plus 14 plus 7y. And we add our like terms, and you get 14 equals 14, which we know is a true statement. And we would graph that. And if we were looking at the solution, we're going to say that solution is infinitely many. If you were to have graphed these two lines in slope-intercept form, you should have found that they are going to give you the same line. In this next one, we know y equals 3x minus 11, so we're going to replace that with the first y. So this is our first y, right here. That's y, minus 3x equals negative 13. As we look at that equation, we're going to add our like terms, which gives us negative 11 equaling negative 13. False statement. So we have no solution for a problem. The sub is going to give you the homework quiz that you will be taking today in class. So you will do this quietly and then work on your assignment, which is in the workbook, G5. And you should have that ready for class tomorrow. And I will answer a few questions on that.